Physical quantities, units, and measurements. Mastering the basics. Hey there, O-level physics students! Ever wondered how we describe the world around us with numbers? Get ready to unlock the secrets of physical quantities, units, and measurements, the foundation of all physics. Physical quantities are things we can measure. Think about it. Length, mass, time, temperature, all these can be quantified. They are the building blocks we use to describe and understand the physical world. These quantities are essential for formulating laws and principles in physics. Without them, we wouldn't be able to make accurate predictions or conduct meaningful experiments. Physical quantities are broadly classified into base and derived quantities. Base quantities are fundamental and cannot be expressed in terms of other quantities. Examples include length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Derived quantities, on the other hand, are combinations of base quantities. Speed, area, volume, and density are all derived quantities. They are expressed using mathematical relationships involving base quantities. Every physical quantity needs a unit to give it meaning. Saying something is 5 long is meaningless without knowing if it's 5 meters, 5 centimeters, or 5 miles. Units provide a standard reference for measurement. The International System of Units, SI units, is the globally accepted standard. It ensures consistency and avoids confusion in scientific communication. Let's look at some common SI units. Length is measured in meters, m, mass in kilograms, kg, and time in seconds, s. These are the fundamental units you'll encounter frequently. Other important SI units include ampere, A, for electric current, Kelvin, K for temperature, mole, for amount of substance, and candela, CD, for luminous intensity. Understanding these units is crucial for solving physics problems. Accurate measurement is vital in physics. We use various instruments to measure different quantities. Rulers, measuring tapes, and vernier calipers are used for length. Mass is measured using balances, and time is measured using clocks and stopwatches. Understanding how to use these instruments correctly is essential for obtaining reliable data. Precision and accuracy are two important concepts in measurement. Accuracy refers to how close a measurement is to the true value. Precision refers to the repeatability of a measurement. A measurement can be precise but not accurate, and vice versa. Strive for both accuracy and precision in your experiments to obtain reliable results. Congratulations! You've now grasped the fundamentals of physical quantities, units, and measurements. This knowledge is the bedrock of your physics journey. Ready to put your knowledge to the test? Practice solving problems involving unit conversions and measurements. Don't forget to subscribe for more O-level physics tutorials.